So here's going to be the solutions to our second day of U substitution. Don't forget, again, we have all these ideas. We see a function and a function. We see a function and its derivative. We see functions separated by a single degree. If we only see one radical, one e-value, one trig function, we pick what's inside it, versus if we see two of any of those things, we pick the entire function. And if all else fails, pick the denominator, look for the more complicated function. So number 9, I see that I've got my derivative for something cubed because I've got something squared. So I pick my 5 minus v cubed, take its derivative, gets negative 3v squared. I don't have that correct coefficient, so I'm going to divide by negative 3 on both sides. So I'm able to rewrite my integral, negative 1/3 integral of du over u, or as some people prefer, they like to use the 1 in their numerator and put the du to the side. Whether you recognize it at this step or whether you end up rewriting it as u to the negative first du, but this is that special case that we're supposed to recognize as our natural log. So I get negative 1/3 natural log absolute value of u, substitute in my 5 minus v cubed, and I'm done. 10, a little bit easier to see that I've got a function and a function since I've got the 2x squared plus 6x plus 1 to the 1/5 power. It is going to require me, once I take my derivative, 4x plus 6, to factor out a 2, since in this group I've got 2x plus 3. Now my value matches, I just have to divide by the 2 to get the 1/2 on the other side. I'm able to rewrite my integral. This is just an anti-power rule problem, so I add 1 to my exponent, divide by my new exponent, which is like multiplying by the reciprocal, and then I have my final answer. 12, just trying to remind you that you don't always have to do something about the coefficient. We can see we've got a function and a function. We can see we got its derivative, so I pick t cubed plus 1. Now in this case, we do end up with the correct coefficient of 3, so I don't need to multiply or divide by anything. I can just go ahead and rewrite my integral, use my anti-power rule, and substitute back in. 14's the same. I can see my function in the function is 1 plus x cubed, and I in fact have the correct derivative. I have the correct coefficient. So when I rewrite my integral, I don't need to have anything in front of the integral sign because I have the correct coefficient. So I've got u to the negative 1/5. I rewrite using my anti-power rule, negative 1/4 u to the negative 1/4, and then substitute my u value back in. 15, it's obvious that we've got a function and a function, but it can feel like we don't necessarily have that function's derivative. But the fact that it's 4s plus 1 and the derivative of that does not have any other variables, and we don't see any other variables in our integral, tells us that we have what we need. I don't have this coefficient of 4 though, so I'm going to go back, divide 4 on both sides, rewrite my integral, use my anti-power rule, and then substitute in my original function. 16's a little tricky because I have a coefficient in the problem already, but it's not going to be the right coefficient, the coefficient I need. So I pick my function as the denominator, t squared plus 1. I take its derivative. I see that I don't have that coefficient of 2, so I'm going to divide by 2 on both sides, and then I can rewrite my integral. Notice the 5 hasn't gone anywhere. It stays in my numerator. Now we have a rule that if we've got a over u du, we know that that equals a times the natural log of the absolute value of u plus c. So that's why my 5 hasn't gone anywhere. I just need to multiply it by my 1/2. And I finish off my 5/2 natural log, substituting t squared plus 1 back in. 17, very similar. I have the correct coefficient this time. Pick my u value, find its derivative. Again, I have the correct coefficient, so I don't need to multiply or divide by anything. So my integral 1 over u du, or some people might write it u to the negative first du, either way we should be recognizing that this is the derivative, the antiderivative for natural log of absolute value of u, and then we rewrite. All right, we're going to keep practicing u substitutions probably for a while. That's one of the most common antiderivatives. If you have any questions still from the homework, please feel free to ask in class.